Okay, I'm going to do the odd ones for you guys, and you guys can do your even ones. I tried to make it for the most part so that every odd problem will match the even one that comes after it. There's like maybe a couple exceptions to that, but for the most part, if you watch the odds, you should be able to handle most of the evens. So integrating these. So what we want to do is first of all, I'm going to rewrite this a little bit. That negative 12 over 5, I'm going to write it like this. And that x, that fifth root of x, I'm going to rewrite it as a 1/5 power. Okay. Then I'm also going to rewrite this one. Whenever you have a variable in the denominator, what you're going to do is you're going to bring it up to the numerator and change it to a negative. And then from there, you go ahead and just use your power rule. The power rule is you're going to add 1 to the numerator. So if you add 1 to 1/5, you're going to end up with 6/5. And then you also divide by that number. But when you divide by a fraction, that's the same thing as multiplying by the reciprocal. Okay. Next one, adding 1 to that, we get -1, and then dividing by a -1, we'll have that. So here the 5's cancel. 6 goes into 12 twice. And, oops, left my x out there. Now the -1 here will cause this negative to become a plus. And so we have 3x to the -1. They may leave it like this. But they could also write it like this. Or I doubt they'll do this, but it's possible to write it like this as well. And technically, if they wanted to write it like that, since there's 6 x's in there, you could take out groups of 5, right? That's how you do a root. So you can take 1 x out for every group of 5. I doubt they're going to do this, honestly. But those are possible answers there. So that's a possible answer. This is a possible answer. I think this is the answer they're going to do. Let's see how they write their answer there on this thing. Yeah, they don't bother with the whole root thing. I just noticed, though, in comparing my answer to theirs, I think I left out the negative. Let me see. Yes, I did. Because this was a -12 here, so that should have been a -2. All right, so that's that. Take a look. So number 2 is pretty similar to that. I'll let you guys follow that one on your own there. Number 3 is a basic u sub problem. We're going to say that u is equal to the inside function there. We're going to take the derivative of u with respect to x. Then we get dx by itself, which would look like this. We're going to replace this with u. And we're going to replace this with du over 16x cubed. And at this point, you shouldn't have x's anymore. And so now we just go ahead and do the power rule like we're used to. We're going to add 1 to that power there, and we're going to divide by that value. Don't forget your plus c. And at the very end, you want to replace the u with what u equals. So it's 4x to the 4th minus 5 to the 5th power plus c. Another way that this answer could be written is instead of putting this whole thing over 5, they could put 1/5 in the front. It means the same thing. Oops. Okay. Let's see how they wrote their answer. Yeah, they put the 1/5 in the front. All right. Next question. Oh, there's the answer. That's for you guys to do though, so I'll let you guys mess around with that one. Let's take a look at this one here. It's another u sub problem. That's going to be my u. Okay. So the derivative of u with respect to x, the 4 goes away. Anytime you have a constant number being added, it just goes to 0. The derivative of that is 1 over negative x times the derivative of the inside, which is negative 1. So it's like a chain rule there. The derivative of the outside is 1 over the inside, and then the derivative of the inside is negative 1. So these negatives just cancel each other out, leaving us with this. So the next thing we're going to do is get dx by itself, and if you cross multiply, you would end up with du times x is equal to dx. So now we're ready for our u substitution. We have 4, and we're replacing this with u, and we're replacing this with x du. So now we have an x on the bottom and the top, so those cancel each other out. And once again, at this point, we should no longer have any x's. So now we go ahead and we add 1 to our power to integrate it, which would give us 4/3. And we divide by that number. However, dividing by a fraction is the same as multiplying by the reciprocal, right? Don't forget your plus c. 4's cancel, and so we're left with 3u to the 4/3 plus c. Now we want to make sure we replace the u at the end with what u equals. U equals 4 plus ln of negative x. Okay. Number 5. I'll let you guys do this one. In this problem, it looks different, but it's really just another u sub problem. There's your u, but I'll let you guys handle that. And it is a chain rule problem, just like the last one was. When you take the derivative, there's a chain rule. Let's go ahead and take a look at this. So now we're going to look at our trigonometric integration. So just to review with you guys a little bit here, the integral of sine is cosine. Actually, I believe it's negative cosine. And the integral of cosine is sine. The integral of secant squared x is tangent x. The integral of cosecant squared x is, I think, when we did it before, it's supposed to come out negative. Negative cotangent x. And the integral of secant x tangent x is secant x. And the integral of cosecant x cotangent x is negative cosecant x. So, there you guys have it. All right, so let's go ahead and take a look at this one. So notice that we have a cosecant cotangent situation. So that's this one down here. But it's also going to be a chain rule situation or a u sub problem because we have more than just an x there. So my u is going to be the inside function there, which is 4x to the 5th minus 1. The derivative of u with respect to x is 20x to the 4th. Getting the dx by itself, we would have that. Rewriting our integral now, we have 80x to the 4th, and then cosecant, and instead of that, we're just going to put u, and cotangent of u, put it in both spots, and then dx we're going to replace with du over 20 x to the fourth. And once again, your x to the fourths cancel out. That's good. And 20 goes into 80 4 times. And so we're just going to pull that 4 out to the front, so the cosecant u and cotangent u are now alone. And so now that we've got it where it's just cosecant and cotangent, just like this thing down here, we could say it's negative 4 cosecant of u plus c. And once again, don't forget to replace the u with what u equals. Okay. So number 8 is pretty similar to that, so I'll leave that to you guys. Number 9, another u sub problem. My u would be the inside function once again, e to the x minus 1. The derivative of u with respect to x is, the derivative of e to the x is e to the x, and the derivative of a minus 1 is 0. Getting the dx by itself, we would have that. Doing our u sub, we would end up with the following. Oops, didn't write that correctly. There we go. E to the x's cancel out, and I'm also going to pull that 4 out to the front. And the integral of sine is cosine. I believe it's negative cosine though, right? Is that right? Yeah. And then we go ahead and do our u substitution, which is e to the x minus 1. The next couple problems we're going to be looking at are the integrals that result in arc trig functions. So when they look like this, that results in what we call an arc sine. Oh, wait a minute, there's no 1 over in the front there. Let me back up a little bit. So arc sine of x over a. So in other words, when you have this little setup over here, oops, get that out of there. When you have this little setup over here, whatever the a is, whatever the x is, it just goes right in here. Now another way to write this, by the way, is with a sign with a little negative 1. It means the same thing as arc sine. So there you go. Let's go ahead and take a look at another one. Another setup that results in arc trig would be the one that looks like this. Let's see, x square root of x squared minus a squared. The difference here is, notice that the x and a have switched roles. They're in different places, and also there's an x on the outside. So that results in an arc secant, and you start off by doing 1 over whatever the a is, and then it's arc secant, and then it's going to be the absolute value of x over a plus c, of course. And once again, they can write it like this. Okay. Next one, last one, is the one that looks like this. When they look like that, that's arctangent. And so it's going to be 1 over a arctangent of x over a. And once again, they can write it like this as well. over a here. Okay, so there's your three possible formulas. So when you guys look at this, you can see this one here, number 11, fits the pattern that we're looking at for arcsecant. So that represents a squared. So if a squared equals 25, that means that a equals 5, right? And so it's going to be 1 over a arcsecant of the absolute value of x over 5 plus c.
What teacher is this?
All right. So there's that. Let's see how they're writing their answers out here. Yeah, they use the secant with the little -1 instead, so just be aware of that. Could go either way. All right, so then this is another one here. Little bit different though. I'll help you guys out with both of these. This one is, first of all, it's a U sub problem. So here's the issue. The first thing you're going to want to do is rewrite it a little bit. It doesn't quite fit the arcsecant pattern, but it's close. Because for arcsecant, it has to be a square and a square. So I'm going to rewrite this inside here as a square. Okay, so if 4x squared equals u squared, then that means that u, if I take the square root of both sides, would be 2. I'm sorry, it's supposed to be 4. If I take the square root of both sides, we end up with 2x squared. So that's going to be my u right there. Okay, so the first thing I did was I rewrote this as a square. And now we're going to do a u substitution. U is equal to 2x squared. Du over dx is equal to 4x. And getting the dx by itself gives us that. Then we're ready for our rewriting here. So we have 4x on the top. Now we have the u in two places. I've got the u here and out here. So I'm going to put it in both spots. All right, I'll see you. And we got du over 4x is what we're going to replace the dx with. So there's our u substitution. Okay, and once again, after you do your u sub, you should pretty much have no more x's in the picture anymore. So now it fits the arcsecant pattern. It has to be a square, so I rewrote this as a square, and that's going to be my u. And after you do your u substitution, you end up with something that actually fits the pattern better. And so this represents my a squared, which means that a equals 2, right? So final answer, 1 over 2, arcsecant of the absolute value of u over 2 plus c. And we'll actually, it's not the final answer. We need to replace the u now with what u equals. U equals 2x squared. Now I'm not going to put the absolute value bars on there. And the reason I'm going to not put them on there is because when you are squaring something, it's going to be positive anyway, so there's no point in having the absolute value bars. It wouldn't be wrong if you included them, but it's just not necessary whenever it's already an automatically positive value. But there's your final outcome. All right, so number 13. What I'll do is I'll give you guys a hint for this one. 2 hints. First of all, we need to rewrite it as a square. Oh, you know what? Actually, there's a little bit more to it. Maybe instead of giving you a hint, I'll work you guys through it. So I'm looking at this, and I notice that neither one of these are perfect squares, right? And so what I'm going to do then, but all 3 of those numbers can be reduced by 2. So that's what I'm going to do is I think I'm just going to reduce by 2 here on the entire thing. So that's going to give me 3x over 4 plus x to the 4th. So I reduced my fraction. You're only allowed to do that if every term present in the fraction can be reduced by the same number, though. Okay, so if I didn't have a 2 here, for instance, I wouldn't be able to do that. But in this case, since all 3 can be reduced by 2, we're good to go. Okay, now it almost fits the pattern for arctangent, doesn't it? But once again, arctangent only works with squares. So I'm going to rewrite the x to the 4th as something squared. So what squared would be x to the 4th? And the answer is x squared. And that's our u, once again. Okay? So from there, I think I'm going to go ahead and let you guys handle it. But we did 2 interesting things here. First of all, we reduced. Second of all, we made it fit the arctan pattern. And now we're going to do some u sub. But I'll let you guys handle the rest. Okay? Okay. Next one here. Let's take a look-see. So here's another one. Now this is not an arctan problem or an arc-trig function. It looks a little bit like the one before it, but here's the difference. Notice that this power is only different from this power by 1. When that happens, what you're looking at is you are looking at a u sub problem where the bottom is the u. Okay, so du over dx is equal to 10x to the 4th, which means that du over 10x to the 4th equals dx. And let's do our u sub. So the x to the 4ths go away, and then 10 goes into 44 times, and then we can go ahead and pull that 4 out to the front. Now this is another integral rule that we haven't seen in a little while. It's probably seen it pretty recently actually. The integral of 1 over u is ln of the absolute value of whatever the denominator is. Don't forget your c. Okay, so now we go ahead and replace the u with what u equals. U equals 2x to the 5th plus 1. We do want to keep our absolute value bars this time because an odd power can result in negatives, and therefore the absolute value bars make a difference here. Okay? So we've looked at a few problems here that involve fractions. Okay? Whenever they only differ by 1 power like that, that's a good sign that you're going to do a u sub with the u being in the denominator. If it's like the ones that we saw before, I'll back up a little bit. Like look here, the power is 4 and the power is 1. They don't differ by 1. That's probably going to end up being an arc-trig function. Alright, so that takes care of 14, 15, 16. Alright, let's go ahead and move on. Okay, so for this one, it's another u sub problem. We're going to let u equal the denominator again. I mean, unless it's one of those arc-trig functions, if you have a fraction problem, it's almost always of the sort where the bottom is the u. Alright, so this is a chain rule. The derivative of the outside is cosine. The derivative of the inside is 3. So there's your derivative. And then, of course, we get our dx by itself, like always. I'm going to go ahead and take this negative 15 out, put it in the front there. I'm going to replace the bottom with u, and I'm going to replace the dx with du over 3 cosine 3x. Okay, so the 3, I'm going to take that out and put it out here also. And the cosines cancel out. So we have negative 15 over 3 in the front, which is just negative 5. And then I'm left with 1 over u du. And that is, once again, an ln problem. And we just replaced the u with what u equals, in this case, 3x. No, it was not 3x. Sorry about that. It was sine of 3x. And we do want to keep the absolute value bars because sometimes sine can be negative. So the absolute value bars actually do matter on this one. All right. Next. For this one, I'm going to let you guys go ahead and handle it. However, I'll give you a suggestion. A lot of times when you're dealing with exponential functions, the u is the exponent. So I'll let you guys handle it from there. Okay? Next one we got is here. Now, this is a special case. Pretty much on every problem we've done so far, the numerator always consisted of just one term. When this happens, when you have two terms in the numerator, what you're probably going to end up doing is splitting it up into two different integrals. This is what I mean by that. So there's that, right? Just split the numerator up into two separate fractions. And then we're going to integrate each piece separately. All right, so really what it turns into is two problems in one. So for the first one, notice the top power is 1, the bottom one is 2. And we talked about how when they differ by only 1, then your u is just going to be the denominator. Okay, so there's my u substitution, and in this case the x's are going to cancel out, and I'm going to bring this 2 out to the front as a half. Okay, running out of space here, so I'm going to write my final result for this one over here. It's going to be 1/2 integral of 1 over u du. I'm going to stop there because I want to work on this one now as well. So let's go ahead and work on this guy. Now, notice the power in the bottom is a 2, but there is no power in the top, so they don't differ by 1 this time. If I go ahead and take this 3 and move it to the front, we have this, and we have two perfect squares being added together. That's an arctan problem. So if I were to integrate this, we're going to end up with 3, and it's going to be 1 over a. In this case, the square root of 4 is 2, so my a is 2. Arctangent of x over 2. And of course, we don't want to be forgetting our plus c, but I'll put that on in a minute. So I'm going to distribute this 3 in. And so now we have 3 over 2 arctangent of x over 2. Running a little tight on space, but I'll squish a little plus. Nope, it won't let me squish a plus c in there, so I'll have to leave it out for now. I ran out of space, but there should be a plus c. This is an ln problem. Okay, and then finally for this u sub problem over here, we need to replace the u with what u equaled. So we have 1/2 ln absolute value of x squared plus 4. And in this case, you really don't need the absolute value bars because this is always positive. So they might just write it like this. Final answer. There you go. So the basic idea is that whenever your numerator has two terms, split it up into two separate fractions and take the integral of them separately, And from there, you're just applying all the stuff that we reviewed in the past few problems to decide how to integrate it. All right, last, I don't know if it's last, it's not the last one. We got more to go. So here is number 18. This is a definite integral. So I think you guys will be able to handle this one okay. But with definite integrals, what you're going to do is you're going to integrate. So I'm going to integrate that, and it's x squared. And I'm going to integrate that, and it's x. And these are my limits. And then we go ahead and we set up our little thing here. So we have plugging in the 3. 3 squared is 9. And so 9 plus 3 would be 12. Plugging in the 2. Negative 2 squared is 4. Plus a negative 2 is 2. Final answer, 10. Definite integrals. Next one. Okay. Arc trigs. Yep, you gotta remember that trigonometry stuff. So look at the pattern. What kind of arc trig integration are we looking at here? This is a, hopefully you recognize it as a secant. So since that's 9, my a value is 3, the square root of it. So we have 1 over 3 arc secant of the absolute value of x over 3 as the integral. And we're going from 6 here and 2 radical 3 here. All right. So go ahead and plug in our numbers here. So I have 1 over 3 arc secant of the absolute value of 6 over 3, which is 2, minus 1 over 3 arc secant of, plug in your 2 radical 3 there. Okay, so from here on out, we're going to have to remember our trig stuff here a little bit. So first of all, arc secant of 2 equals what? Well, if you want to figure out what that is, we're going to do the opposite of arc secant on both sides. So I'm going to do secant on both sides. Secant cancels out arc secant, and so I'm left with 2 equals secant of what? Now, the next thing we have to do is we have to remember what secant is. Secant is the reciprocal of cosine. So secant is 1 over cosine of some angle equals 2. And if I just take the reciprocal on both sides, this just becomes normal cosine, and the 2 becomes 1/2. And so now we're asking ourselves, where on the unit circle does cosine equal 1/2? Remember, cosine is the x value. And when we're dealing with cosecant, secant, we are concerning ourselves with only the top half of the circle. Okay? So where does x equal 1/2? Well, that would be right here, and that's an angle of pi over 3. So that's our missing number there, and therefore up here. So arc secant of 2 is pi over 3. Minus, we get to repeat that here. Now I got to figure out what is arc secant of 2 radical 3 over 3. Okay, so if arc secant of 2 radical 3 over 3 is equal to, we'll say x this time instead of question mark, that means that secant, well, I'll just kind of keep it the same as I did last time so I don't get too confused. That means that 2 radical 3 over 3 is equal to secant of x. Just do the opposite of arcsecant on both sides. Next, we're going to change this to cosine. 1 over cosine of x is the same thing as secant x. And I'm going to turn this into just normal cosine, not 1 over cosine, if I take the reciprocal on the right side, which I'm allowed to do so long as I also take the reciprocal on the left side. And unfortunately, if you're using the unit circle, and you're not going to recognize this because it's not in simplest form, you need to rationalize it. So I'm going to multiply the top and the bottom by the square root of 3. Okay, and so that leaves me a 3 square root of 3 over 2 times, that makes 3, so 6. And then we're going to reduce the 3 over 6 there, and we end up with this. So now we're asking ourselves, where does cosine equal radical 3 over 2 on the unit circle when we're concerned with just the top half? So that would be right here, and that angle is pi over 6. Okay? Okay, so multiplying 1/3 times pi over 3, we're going to end up with pi over 9, minus 1/3 times pi over 6 is going to be pi over 18. Let's get a common denominator here so we can actually do the subtraction. And we get 2 pi over 18 minus pi over 18, which gives a final answer of pi over 18. All right, so definite integrals with arc trigs. Let's take a look at another one here. We have a definite integral with regular trig. A little bit more chill, I would think. Okay, so first of all, let's pull the 2 out to the front here. You could leave it inside if you wanted to. I'm just going to pull it out though. Now we're going to integrate sine. The integral of sine is negative cosine. Now we'll do our substitution and subtraction, applying the first fundamental theorem of calculus. So I'm going to plug in the 2 pi over 3. And then I'm going to plug in the pi over 2. Okay, so cosine. So first of all, when you're dealing with cosine, once again, we're looking at the x values. 2 pi over 3 is right here, so cosine of that is asking what's the x value at that point. And the x value at that point would be a half. And there's a negative there in the front. We don't want to lose that. Minus, let's do this one here. Pi over 2 is up here at the top. The x value at that point is 0. So we have 0. So I don't really care about that. But we still have this 2 in the front. So what's 2 multiplied with a negative 1/2? Well, you end up with 2 over 2 with a negative front, so the answer is negative 1. I believe that does it. So hopefully that was helpful to you guys. And we'll see y'all later.